Welcome back. Today we're going to talk about optimization. Optimization is just to find the maximum or minimum for word problems. So you want to maximize or minimize certain quantity. Here we start with a simple example. Say sum of two positive numbers is given 16. What is the smallest possible value of the sum of their squares? So it means if you have two numbers, x and y, you add them together, it's given that the sum is 16. And let's consider the function f, which is a function of both x and y. Let me write it this way first, then. This means the function f depends on both x and y. And what is the function f? It is the sum of their squares, the sum of squares of x and y. We want to the question is, what is the smallest possible? So we want to find out what is the minimum of f. This is the question that we want to answer. But we haven't learned how to deal with multiple variables. So what we need to do is, using the given data, given information, x plus y equal to 16, we want to get rid of one of these variables. So let's say I can write x or y in terms of x. Y would be 16 minus x. So therefore, I can write the function f not in terms of x and y, but only in terms of x, by replacing y with 16 minus x. So what we have is x squared plus 16 minus x instead of y, and that is squared. So now the question is, what is the minimum of f? It's the same question. Instead of having two variables, now we have one variable. Now I can answer this question. Given a function f, find out what is the minimum. And this is, we're looking for either absolute minimum or local minimum, depending on the question. So in this case, we're looking for local minimum. Normally, it's going to be the absolute minimum as well. So what do? Find the first derivative, f prime x. By the way, this f, you can choose to call it something else. You can call it area of x in case we deal with the area. But I'm going to call it f in this case. F prime x would be 2x plus 2 times 16 minus x, multiplied by the derivative of inside by chain rule, so multiplied by -1. So f prime x would be 2x plus 2 times 16 is 32, minus 2x, and there is a -1 outside, multiplied by that. So I can write it as minus, which you can simplify it as 4x minus 32. So we want to find out the critical number f prime. What is the critical number? This is where the derivative is 0. So in this case, 4x equal minus 32 equals 0, which is x equals to 8. So now if you draw the number line, here's f prime, here's 8. We want to make sure that 8 is a minimum, because we're looking for the minimum. Not always it's going to be the minimum. So here you pick test points. Pick 7, pick 9, and pick any other number. Replace it into the first derivative. What you get is 4 times 7 minus 32 is 4 times 7 minus is a negative number, and 9 times 4 plus, okay, so this is a positive number. It means you have a decreasing then increasing function. That means this point 8 is the minimum point, local minimum. It means I found out what is x. The x was 8. You can find out what is y. Y would be 16 minus x. Have that. So 16 minus 8 would be 8. So we found the two numbers that they sum up to 16, and if you square them and add them up, that would be the minimum possible value for the sum of their squares. You can test this theory. Let's say, okay, we have 8 squared plus 8 squared. That is 64 plus 64 is 128. On the other side, if you pick any other number that sum up to 16, something like 10 and 6, what you get is, as the sum of the square would be 10 squared plus 6 squared, would be 136. You see that this is the smallest compared to 10 and 6. Any other possible combination, if they add up to 16, it's going to be larger than 128. So we found the minimum. Just one thing that you should notice is that this two numbers is given already positive. So if you're picking test points, make sure that you stop the test points at 0. Do not go beyond this, because that means you're picking negative number. It's important that you make sure that you stick with the domain of given. If they say two positive number, you're only allowed to go up to 0, not beyond that. Okay, next example. What is the minimum vertical distance between two following parabolas? So you're given two graphs. To give you an idea of what this means is you have two graphs, maybe something like that, and another one. And they say, if you look at 2 points above each other, they have a distance between these two. If I look at these two, there's a distance between these two. We want to find out what is the smallest distance. Which 2 points have the smallest distance, or what is the smallest distance? That's the question. So what is the smallest distance is the difference in the y's. So this y minus the other y. This is function 1, y1, and this is the y2. We're going to find out what is the smallest difference between the y's. If you have another point, there will be different y values. So how do we find the minimum? We say, okay, there's a function f that represents the minimum. And what would be the minimum? It would be the difference in the y's. We want to find out what is the minimum of x squared plus 1 minus x squared. This is the question. What is the minimum of f? X. Okay. So we're looking for the minimum vertical distance between the two parabolas, and we need to find out the difference between the y's. Okay, how do we find the minimum? Again, take the derivative. F prime x would be 2x minus 1 minus 2x. You could simplify the f a bit. I decided just to write it as it is. And if you simplify it, you get 4x minus 1. Again, critical number, you can find the critical number. In this case, x would be 1/4. That means at some point here, 1/4, you will have the smallest distance between the two functions. These two graphs that I drew is not accurate. It's just as an indication to how it will look like. The other graph is probably upside down. So this is the point 1/4 where they have the smallest distance. It'll look like something like this. Okay. You can draw a number line to make sure that 1/4 is the smallest y value or is the local minimum. Okay, so here if you find 1/4, absolute minimum, sorry. If you find the 1/4 and pick test point on each side, I'll pick 0 and 1, replace it in the first derivative. If you replace 0, you get negative. If you replace 1, you get positive. We're replacing into the first derivative. And decreasing, increasing, that means yes, there is a minimum. Local minimum. So what does it mean? It means at x equal to 1/4, we achieve the local minimum. This is where the local minimum happens. But what they ask you is what is the minimum vertical distance between the two? That means find out what is f of 1/4, because we want to find that distance. So replace 1/4. What you get is 1/4 squared plus 1. You write it with a different color. So here, 1/4 squared plus 1 minus 1/4 minus 1/4 squared. Always make sure that you understand the question. If you calculate this, this would be 1/16 plus 1 minus 1/4 plus 1/16. This is 1/8 minus 1/4 would be negative 1/8, so you will get 7/8. And that is the minimum distance between the two functions. Okay, so this height at 1/4 you have is 7/8. That's the height that we have. The distance is minimum distance between the two graphs are 7/8. Okay, another type of question would be find the point on a line which is closest to the origin. And these are all common questions. That's why I picked them. So you've seen similar questions before you do the homeworks. Here. If I can shift this up a bit, that'd be great. Okay, it's not possible. So here, let me give you an idea. What does it mean? Let's say this is a straight line, but let's say you have a curve or whatever. It doesn't really matter. And you're given a point. They say find the shortest distance between the point and the curve. What is the minimum distance between the curve and the point? What you need to do is from every other point on the curve, you connect it to this point, find this distance. Could be from here, here, from anywhere. And you want to find out what is the minimum of this distance. So you'll pick points on the curve and you want to minimize distance. So how do you pick points on the curve? It should satisfy the equation of the curve. So if you pick x, for example, in our case we have a straight line, so let me draw the straight line. So if we consider this line as 2x plus 3, y equals 2x plus 3 is the slope positive. Here y equals 2x plus 3, and here's the origin. You want to find out which point on this graph gives you the shortest distance to the origin. This distance compared to this one, compared to this one, which one is the smallest? These are all possibilities. And what you need to know is if you pick a point on the line, what is the coordinate of that point? You have the x coordinate, and what is the y coordinate? The y coordinate is given. It's depending on x, it's 2x plus 3. Because y is given 2x plus 3. We want to find out the distance from that point to the origin. The origin has coordinates 0 and 0. And what is the distance formula? The distance is, if you remember, the distance between 2 points, write this. Distance between x1, y1 and x2, y2 happens to be square root of x1 minus x2 squared, or x2 minus x1 squared, doesn't matter, plus y1 minus y2 squared. This is the distance formula. In this case, we want to find the distance between origin and that point. So what would be the distance function? It would be square root of x minus the origin is 0, x value, plus squared, plus y2 minus y1. y2 is 2x plus 3 minus y1, which is the origin y value, which is 0. So we want to find out this distance and minimize that. So the question is, what is the minimum of the distance? Okay, now that we understand the question, we can find out what is the minimum. Take a derivative. First simplify it. Let's simplify dx a bit. It is x squared plus 2x plus 3 squared. The zeros do not make any difference. Okay, you can write it as power 1/2 if you want. X squared plus 2x. Yeah, you can square this one as well. 2x plus 3 squared would be, let me write these steps, 4x squared plus 2 times 2 times 3 is 12x. If you distribute that, if you distribute 2x plus 3 by itself, multiply it by itself, you get 4x squared plus 12x plus 9. And this is to the power 1/2, which could be simplified to 5x squared plus 12x plus 9, the power 1/2. So now again, what we want to find out is the shortest distance, the closest point. We need to find the derivative. What is d prime x? It would be 1/2 5x squared plus 12x plus 9 to the power -1/2 times the derivative of the inside. Derivative of the inside is 10x plus 12. And simplified version of this, 10x plus 12 in the top, and 2 to the 1/2 gives you a 2 in the denominator, multiply by square root of 5x squared plus 12x plus 9. Okay, what is the critical number? Critical number would be zeros of the numerator and denominator, but denominator, this is always positive because it was sum of two squares. Remember, this was this square plus that square, so it's always positive, so you don't get 0 in the denominator. The only 0 would be from the numerator, and x plus 12 equal to 0, which gives us x equals to -6/5. This is the critical number. Then draw the number line. Here's for f prime. Here is -6/5. And we pick test point on each side. I pick -2, for example, and 0. Place -2 into the derivative. Again, denominator is always positive, so you don't really care about the denominator. If you replace -2 in the numerator, what you get is a negative number. Divide by positive, it's a negative. And here, if you replace 0, you'll get positive 12 in the numerator. So decreasing, increasing. Means -6/5 is the minimum. Means we found the minimum of the distance found the x value for the minimum of the distance. So how do we find the minimum distance? Minimum distance would be evaluate d at the -6/5. Means replace -6/5 into the equation for d. Is -6/5 squared plus 2 times -6/5 plus 3 squared. This is a number, whatever that number is, you can calculate. I'm gonna stop at this point and say, okay, this is that number, and which is the minimum. You can use decimal value if you want. You can leave it as exact, the square root. Okay. Here another example. 1200 centimeter square of material is available to make a box with a square base. So, and with the open top, find the largest possible volume of the box. So let's see, what does it mean? It means you're given a box. The only thing you know about it is square base, so the top would be square as well. This you should imagine this in 3 dimensions. So there is a back and kind of like, okay, this box is open on top, so the top is empty, but you have a base which is a square. This is a square, and it means this length is the same as that length, but the height of the box is not given, so we don't know what is the height. I'm going to call it y. That again on all sides. The top would be x again, since they are square base. What is the given information? The given information is there are 1200 centimeters square of material. And how do you use the material is for area around and the bottom, since the top is open. So what is the total area? So the area for this box would be, consider this side, the area of this side, the area of the other side, and the one in the back, and the other side. So you would have four sides to consider. Erase these. So you have 4 areas of each side, which would be x times y on each side. So 4 times y areas. Again, each rectangle has lengths x and y. 4 of these. One here, the one, second one. There's a third one on the back. This one. They all look the same, exactly x times y. So that would be the area of the sides and the bottom, since the top is open, since we have only the bottom. So plus x times x, which is x squared. This is the total area. total area. But this is given because it's 1200 centimeters square. So 4 times xy plus x squared is given 1200. I'm going to write it smaller. 4 times xy plus x squared equals 1200. Again, we have more than one variable, so I rather get rid of one of the variables before I get to deal with the next step. So I will write what is y, move the x squared to the other side and divide by 4x. It would be 1200 minus x squared, the whole thing divided by 4x. This is how we find y by itself. So in case if it's necessary, I'll replace y with this. Okay, what do we want to do? We want to find the largest volume possible. What is the volume? The Vx. Volume of the box would be, actually it depends on both x and y. It would be length times width times height. So it would be x times y. X times x times y. But again, since we found y, I can replace y with x squared times 1200 minus x squared divided by 4x. This is how we replace y, and this is the use of y. And if you simplify it, it'll be x squared. One of the x's will cancel out with here. We get 1200 times x divided by 4 would be 300x, and x times negative x squared divided by 4 would be minus 1/4 x cubed. This is the simplified version of v. And what we want to do is now to maximize. We want to find maximum of v is the question. If they ask you what are the sizes, you have to find x and y. If they want you to find the maximum of v, that means give the volume at the end. Okay, so find the v prime x, which would be 300 minus 3/4 x squared. Find the critical number. It happens to be where 300 3/4 x squared equals 0. Multiply with 4 divided by 3. And if you simplify, x squared would be 400. That means x could be plus or minus 20. This is one thing you should notice. Since you're dealing with length of a box, you can never have negative number. So I'm going to ignore the negative. The x must be 20. You can draw the number line again to test, see if it's really the maximum point. Derivative here is 20. Pick a number. Again, since it's length, I'm going to pick positive numbers, 3, 10, and 30. Replace 10 into the derivative. It would be positive number here, and you would get negative on the other side. So increasing, decreasing. That means yes, 20 is a maximum. If you find x, you should be able to find y as well. But they're not asking for y. They want to find the maximum volume. So we want to find out what is v of 20. Replace 20 for the function v. Replacing 20 here. The simplified v based on x. Be 300 times 20 minus 1/4 times 20 cubed. Simplify that. Let me see if I can do this faster. It'd be 20, 100, 200 times 20. It'll be 4,000. Okay, so 4,000 centimeter cube is going to be the volume. This is going to be the maximum volume possible. Any other lengths that you pick for the sides, for the base and the height, and to satisfy that 1200 centimeter of material usage, then you're not going to get the maximum volume. This is the only time that you will get the maximum volume. Okay, one more. Actually, two more. Another one that relates to the area, then the next one is a business question. The poster is to have an area of 180 inch squared. Okay, so we have a poster. We don't know the length and height. We know that all this x, all this y. And they say with 1 inch margin. 1 inch margin at the bottom 1 inch and at the side. Means from here you have 1 inch margin. From the side you have 1 inch as well. 1, and here 1. And from the top we have 2 inches. From the top we have 2 inches. Find the dimension that will give us the largest printed area. So we want to maximize this area. Okay. What are the given information? Given the information is total area is given 180 inches square. So what we know is x times y equals 180. So I can find again y in terms of x, 180 divided by x. So if I need to get rid of y, I will use this 180 divided by x. What we want to maximize is the area. Area of what? Area of this red section. This red section has the length. Here, this length would be exactly x, but subtracted 1 from each side. So x minus 2. This is x minus 2. And the height would be y minus 3, because you subtract 1 from the top and 2 from the bottom. So the area would be x minus 2 times y minus 3. And we want to find the maximum of this area. Again, since it's in 2 variables, you try to get rid of one of them. You can write it as x minus 2 times 180 over x minus 3. Okay, so I'm going to call it the function ax, the area of x, which would be, you can simplify it. X minus 2 times 180 over x would be 180. Distribute this term by term. 180 x times minus 3x. Negative 2 times that would be minus 360. Sorry. 180 times, yes, 360 over x, and negative 2 times negative 3, positive 3. Okay, so now what we have is, you could simplify this. Sorry, positive 6. Why did I write positive 3? So you can simplify ax to negative 3x minus 360 divided by x and plus 186. Okay, so this is the area function. When I'm finding the maximum of the area. To take a derivative, question is max a. A prime x would be negative 3 minus, you can use the quotient rule, or you can write it as 360 times x to the power negative 1. Whatever you do, at the end you'll end up with 360 over x squared. The practice, try this. This is the derivative. The derivative of 186 is 0. To find out where the critical number happens, that means where 360 over x squared minus 3 equals to 0 or equals to 3. Now, by doing this, what we get is x squared equals 120. And what is the square root of 120? X would be square root of 120. That is, let me write it as square root of 120. I want to simplify it, but it's 2 square root of 30. I cannot do more than. I was hoping you could do more than that, but it seems like it's not possible. Yes. Hope I didn't make any mistake anywhere. Okay, so we found x. What is y? You can find y as well, but it's not necessary unless they ask for it. So we want to find out the maximum of a. What is max a? Replace this 2 square root of 30 into the function a. And the simplified version of a is here, only depending on a. I'll say maximum a would be negative 3 times 2 square root of 30 minus 360 divided by 2 square root of 30 and plus 186. By the way, you have to check to see if that point is really the maximum. 2 square root of 30. You can pick test points on each side, and you will notice that you will have an increasing then decreasing. Therefore, this point would be a maximum. I skipped over these steps because we've done it already for 4 examples. And you can simplify this number. Try to get rid of the square roots in the denominator by multiplying a root 30 in top and bottom. You can simplify it this way. Okay, that's maximum A. These are similar questions, so I didn't spend too much time on them. Here's another one that is for business majors. Demand function for a certain commodity is given as Px, where P is measured in dollar and X is the number of units produced to sold. So the total cost of producing X item is given. So this is the cost function, and we have here the demand function. Determine the total, the level of production that maximizes the profit. So first we want to find out what is the profit function. So here is one thing that you should know. The total revenue function means the total income is the demand function multiplied by the number of units you're selling. So if you're selling 10 items at the price of some $10, then demand would be $10 times number of items, 10x. So in this case, it would be Px times x. So it would be 10 minus 0.001x times x. This is the revenue function. What is the profit? The profit would be total income minus the cost function. The total income is the revenue function, or x, minus the cost function, px. So for us, the px function would be rx, which I can simplify it to 10x minus 0.001x squared minus the cost function, which is 50 plus 5x. Use parentheses. So this is revenue minus cost. And if you simplify it, 10x minus 5x is 5x. And we have minus 0.001x squared and minus 50. This is the profit function. We found the profit function. What we want to do is find the maximum of the profit. So take a derivative and set it equal to 0. P prime x would be 5 minus 0.002x. So what is the derivative? What is the critical number? Happens when 5 minus 0.002x equals 0. Therefore, x must be 5 divided by 0.002. That means this is what 5 divided by 0.002. Sometimes I wonder why do I pick these numbers. 2,500. I divided by that. I'm guessing that is correct. 5 divided by 1,000 is 5,000, and divide by 2, yeah, 2,500. So you found x, so find out the profit at 2,500 units. X is the number of units you need to make or you need to sell. So it would be, profit would be 5 times 2,500 minus 0.001 2,500 squared minus 50. Whatever this number is, that is going to be maximum profit. Again, I didn't check for the derivative to see if it's a maximum point. F prime 2,500. But you have to check to see if this point is really maximum. The only thing is, if I pick a test point like 10 or 1,000 or whatever, I have to replace it in here, P prime, and see that this would be positive. the other side, if you pick something like 5,000 and replace it in the p prime, what you get is negative number. So you have an increasing then decreasing. Means the 2,500 is where the maximum happens. The maximum profit would be whatever you get throughout these calculations. Okay, I hope you calculate these numbers and fill in the blanks. Okay, I think this is good enough of examples for this section. I've picked six examples that are very similar to your homeworks. So start to do the homeworks, and I will stop at this point.